Everyone, welcome to my YouTube channel Easy Way to Learn. I'm Shalja Tripathi and in today's math series we'll be doing word problem on trigonometry. So remain focused, follow the series and let's get started. So our first question is, from the top of a cliff 60-meter high, the angle of depression of top and bottom of tower are observed to be 30 and 60 degree. Find the height of the tower. So let's begin by drawing the figure first. So first we'll draw the figure. See, so tower is being observed from the top. So this is cliff which is 60-meter high and tower is, let the height of the tower be h. Then we draw a a line parallel to the ground. So we get two right angle triangles. Let's label it A, B, C, D and E. And the distance between tower and the cliff be x. See, this AE distance is already given, that it is 60-meter high. So AE is cliff which is 60-meter high. So BE distance will be h, because we are getting a rectangle here B, C, D and E and opposite sides are equal. So this CD is H, so BE is also H and AB will be 60 minus H. So with this figure now we'll solve the question. See, in the bigger triangle ADE, in triangle ADE, we can write tan 60 is equal to, so this is 60 degree and this is 30 degree. So tan 60 is AE upon ED. So we can write AE upon ED. See, AE is 60 meters. So let's put the values. Tan 60 is root 3. AE is 60 and ED is supposed to be x. So let's find the value of x. We get 60 upon root 3. On rationalization, we get multiply numerator and denominator by root 3. So we get 60 into root 3 by 3. That is, value of x comes out to be, x is equal to 20 root 3. So this will help us to solve the question further. Now let's take a smaller triangle ABC. See, in triangle ABC, tan 30 is equal to, again, perpendicular upon base. So here perpendicular is AB and base is BC. So let's put the value. AB is tan 30 is root 1 upon root 3. AB is 60 minus H. 60 minus H. And BC is equal to ED because BCED is a rectangle. So here you can write BC is equal to ED. So ED we have already assumed it to be x. So x, put here x, and we will place the value 20 root 3 in place of x. 1 upon root 3 is equal to 60 minus h upon 20 root 3. See, root 3 will cancel out. What we get? 20 is equal to 60 minus h, or h is equal to 60 minus 20, that is 40 meter. So this is the answer. The height of tower is 40 meters. Hope. Let's see this question. See, an aeroplane is flying horizontally 1 kilometer above the ground and is going away from the observer. Is observed at an elevation of 60 degree. After 10 seconds, elevation is observed to be 30 degree. Find the uniform speed of aeroplane in kilometer per hour. Okay. Again, to understand this question, first we'll draw the figure, and whatever is asked, that is, we have to find speed. So let us assume that speed of the aeroplane is, let speed be s kilometers per hour. Okay. See, first we draw the ground level. See, if this is the aeroplane and the observer is seeing it from this point, an aeroplane is 1 kilometer above the ground. So this distance is 1 kilometer. At this point, angle of elevation is 60 degree. After 10 seconds, the elevation changes. Let us assume this aeroplane is here. Again, see, again aeroplane is 1 kilometer above the ground, and so this angle becomes 30 degree. That means after 10 seconds it has covered this much distance. Again, it is 1 kilometer above the ground. So this is the question, that aeroplane which is 1 kilometer above the ground, initially its angle of elevation was 60 degree. After 10 seconds, elevation changes to 30 degree. We have to find the speed of the aeroplane. Okay, so let's label the diagram A, B, C, D and E. See this distance, let us assume this distance to be x, and CD distance can be calculated because time is given and speed is given. So we'll use the formula distance is equal to speed into time. So speed we have already assumed to be s and time is 10 seconds. So 10, and then we'll convert into r, that is divided by 60 into 60. So what we get, distance is s upon 360. Now we can use the trigonometry, that is in triangle, right angle triangle ABC, in triangle ABC. See, we get tan 60 degree is equal to AC upon BC, that is AC upon BC. AC is already given 1 kilometer and BC we have assumed it to be x. Tan 60 is root 3. So the value of x is 1 upon root 3. So this piece of information will be useful in solving the question. Similarly, in triangle BED, in triangle BDE, we can write tan 30 is equal to ED upon BD. Again, tan 30 is 1 upon root 3. ED, that is, it is 1 kilometer above the ground, 1 upon BD. So BD is equal to root 3. Okay. See, BD is written as BC plus CD. So BD is written as BC plus CD. And BD is root 3. We'll put the values. BC is x and the value of x is 1 upon root 3. 1 upon root 3. CD, okay, CD is S upon 360 kilometers that we have found out here. So we'll put S upon 360. Okay. See, we can rationalize this number 1 upon root 3 and solve it, or otherwise without rationalization also we can solve it. See, LCM will be 360 into root 3. So what you get here, 360 plus root 3s is equal to root 3. Okay, we'll cross multiply, we'll get 360 into root 3 into root 3 is 3. So you get here 3 is equal to 360 plus root 3 s. Now let's solve it. We get 360 into 3 minus 360 is equal to root 3 s, or we get 2 into 360 divided by root 3 is equal to s. Okay, again to the rationalization. So we get 2 into 360 into root 3 into root 3. So root 3 into 3 is 2 times root 3 is 3. So we can write 2 into 360 into root 3 upon 3 is equal to s. Now solve it. You get 2 into 120 into root 3. That is 240 into root 3. On solving this, you will get the value of s. That comes out to be 415.680 kilometer per hour, and this is your answer. So the best way of solving these questions is, first understand the question, draw the figure, and then start solving the question. See, in this question, it is saying a man in a boat rowing away from a lighthouse 150-meter high takes 2 minutes to change the angle of elevation of top of lighthouse from 60° to 45°. Find the speed of boat. So let's draw the figure first. Okay. This is lighthouse which is 150-meter high and it is being observed from a boat. So the angle of elevation is 60°. After 2 minutes, the angle of elevation changes to 45 degrees. And this change takes place in 2 minutes. So this distance is being covered, means this distance is being covered in 2 minutes. So if we find the distance and we have time, so we can find the speed. So let's label the figure A, B, C and D. AB is given 150 meters. So let's solve this question. Let's take this triangle ABD. So in triangle, and let's BD X. Okay. In triangle ABD, we can write tan 60 is equal to AB upon BD. So let's put the value. Root 3 is equal to 150 upon X, or X is equal to 150 upon root 3. Rationalize this number by multiplying and dividing, by multiplying numerator and denominator by root 3. You get 50 root 3. So the value of X, that is BD, is 50 root 3. Okay. Now let's take this big triangle ABC. In triangle ABC, we can write tan 45 is equal to AB upon BC, perpendicular upon base. Tan 45 is 1, AB is 150, so BC you can find out. So BC comes out to be 150 meters. See, from these two data we can find the value of CD. So CD is equal to BC minus BD. So let's put the value 150 minus 50 root 3. Now what we can do, we can take out 50 common. You get 3 minus root 3. So this is the distance. Time is given 2 minutes. Now we can find the speed. So speed is equal to CD, distance covered, upon time taken, time to cover the distance. So now we have 50 bracket 3 minus root 3 divided by 2 into 60. Convert the minute into seconds so that we can get the speed in meters per second. See, on solving this we get 25 into See, 3 minus root 3 comes out to be 1.268 divided by 60. You solve this, you will get the answer 0.52888 meters per second. So this is the answer for this question. See, in this question, it is said if a man is standing on a platform 3 meters above the surface of a lake, observes a cloud and its reflection in the lake, then the angle of elevation of cloud is equal to angle of depression of its reflection. We have to show whether this statement is true or false. So that we are going to show. So let's draw the figure first. See, if this is the lake and a man is standing 3 meters above it on a platform, 3 meters above, and he is observing cloud. From this point he is observing the cloud, and at the same time he is also observing the reflection of the cloud which is formed in the water. Okay, so the person is also seeing the reflection. Now we have to show that angle of elevation is equal to angle of depression. So what we'll do, draw a line parallel and then we draw this distance also. So if the man is standing here and observing, let this angle be theta 1. So angle of elevation is theta 1 and angle of depression is theta 2. Let this height be h and this is already given 3 meters because the platform is 3 meters above the lake. So this is our lake. So this distance will be, again reflection will be 3 plus h distance below. So this will be 3 plus h. So let's label the diagram A, B, C and D. Okay. Now in triangle ABC, in triangle ABC, see, tan theta 1 is equal to BC upon AC, or we can write theta 1 is equal to tan inverse BC by AC, and BC is nothing but H. So you can write tan theta 1 is equal to, theta 1 is equal to tan inverse H upon AC. Now we'll take triangle ACD. See, in triangle ACD, we get tan theta 2 is equal to, again perpendicular is CD upon AC. Base is AC. Okay. So CD can again be written as, CD can be written as H plus 3. So write CD as H plus 3. Okay. So theta 2 is written as tan inverse H plus 3 upon AC. See, now compare the values theta 1 and theta 2. See, on comparing the values of theta 1 and theta 2, we see theta 1 is not equal to theta 2. So, theta 1 is not equal to theta 2. So, this statement that both angle of elevation and angle of depression are equal, this statement is false. So, the statement given in the question is false. So, this will be your answer. See, in this question, the angle of elevation of top of a tower from certain point is 30 degree. If the observer moves 20 meters towards the tower, the angle of elevation increases by 15 degree. Find the height of the tower. So from this question, first let's draw the figure. Okay. See, if this is the tower, okay. See, angle of elevation from certain point is 30 degree. See, 30 degree. And the observer is moving towards the tower. This is our tower of height h. And when the observer moves 20 meter towards the tower, so elevation increases by 15 degrees, that is, it becomes 45 degrees. So this distance that is covered is 20 meters. And let's suppose this distance be x meters. Okay, now we have to find the height of the tower. So in triangle ABD, let's take triangle in triangle ABD. Apply tan 45 is equal to perpendicular, that is AB upon BD. So tan 45 is 1, AB is H and BD is X. So we get a relationship that X is equal to H. Let this be equation 1. Now in triangle, now let's take a bigger triangle ABC. So in triangle ABC, we can write tan 30 is equal to AB upon BC. AB upon BC. Let's put the value. Tan 30 is 1 upon root 3. AB is H and BC is X plus 20. Okay, now in place of X we can write H using relationship 1. So it can be written as 1 upon root 3 is equal to h upon h plus 20. So we are using equation 1. Using equation 1. Now let's solve and get the value of h. So we get h plus 20 is equal to root 3h, or 20 is equal to root 3h minus h. That is 20 is equal to h root 3 minus 1. On transposing, we'll get 20 upon root 3 minus 1. Now rationalize this value. See, 20 multiplied by root 3 plus 1, root 3 minus 1, multiply it by root 3 plus 1. On solving, we'll get 20 into root 3 plus 1 divided by, now using the identity a plus b and a minus b, we get a square minus b square. So here we get 3 minus 1, that is, on solving this we get here 2. So our answer is 10 multiplied by 2.732, or you get 27.32 meters. This is your answer. Hope you understood the solution well. Let's come to the next question. See, in this question, the angle of elevation of top of tower 30-meter high from the foot of another tower in the same plane is 60 degree, and the angle of elevation of the top of second tower from the foot of first tower is 30 degree. Find the distance between the two towers and the height of the tower. So we begin the questions by drawing the figure. Okay. So let's see, this tower 30-meter high is being observed from the foot of another tower. So this is 30-meter high tower, and it is being observed from another tower, from the foot of the another tower. So this is angle of elevation, 60 degree. Now it says the angle of elevation of top of the second tower. So this is our tower 1 and this is tower 2. See, angle of elevation of top of the second tower from the foot of the first tower is 30 degree. So join this and you get this angle 30 degree. So we have to find this distance between the towers. Let this be x meters. Okay, let's solve this question. See, in triangle A, B, C. See, we can write tan 30 degree is equal to AB upon BC. AB is H and BC is X. See, tan 30 is 1 upon root 3. This is equal to H upon X. Or we can write H is equal to x upon root 3. So this is the relationship that will help to solve the question. Okay. In another triangle BCD. So let's take this triangle. In triangle BCD, what we get, tan 60 is equal to CD upon BC. Tan 60 is root 3. CD is already given 30 meters, and BC is x. So we find the value of x, 30 upon root 3. Now rationalize this number. So we get x is equal to 10 root 3 meters. So distance between the towers is 10 root 3. Now put the value. Now put the value of x in this relationship and you get the value of h. So we get h is equal to x upon root 3, that is 10 root 3 divided by root 3. So the height of tower 2 or second tower is 10 meters. So these two are the part of your answer. See, in this question, the lower window of a house is at a height 2 meter above the ground and its upper window is 4 meter vertically above the lower window. At certain instant, the angle of elevation of a balloon from these two windows are observed to be 60° and 30° respectively. Find the height of balloon above the ground. So again, to solve this question, we'll first draw the figure. See, this is the wall of the house. This is the ground level and window is 2 meters above the ground. See, another window is 4 meters above the lower window. So this distance is 4 meters above the lower window. See, balloon is being observed from this window. So the angle of elevation is 30°. And from the lower window, the angle of elevation is 60°. So let's label the figure A, B, C, D and E. See, in triangle ABC, first we take triangle ABC. In triangle ABC, what we get? Tan 30 is equal to AC upon BC. Okay, let this distance AC be H. Okay, and this distance BC, which is equal to ED, be X meters. So now we can write tan 30 is 1 upon root 3 is equal to H upon X, or we can say X is equal to root 3 H. Now let's take another triangle AED. See, in triangle ADE, See what we can write, tan 60 is equal to AD, tan 60 is equal to AD upon ED. See, AD will be H plus 4 because this CD distance is 4 meters. So this is 4 meters. So we can write tan 60 is root 3, AD is H plus 4 and ED is X. Now from this relationship that we got here, we can put the value of X. So put the value of X from equation 1. So what we get, root 3 is equal to H plus 4 upon root 3H. So cross multiply will get 3H is equal to H plus 4 or 2H is equal to 4 or H is equal to 2 meters. So this distance we have found out, AC is equal to 2 meters. See what the question is saying, find the height of balloon above the ground. So this distance is 2 meters. So 2 meter plus 4 meter plus 2 meters. So we'll get the answer. Balloon is 8 meters above the ground. Balloon is, you can write 2 plus 4 plus 2. That is equal to 8 meters above the ground. So this is your answer. Let's see this question. See, a man on a top of vertical observation tower observes a car moving at a uniform speed coming directly towards it. If it takes 12 minutes for angle of depression to change from 30 to 45, how soon after this the car will reach the observation tower? So we begin this question by first drawing the diagram. See, if this is the observation tower and angle of depression is, person from the top is observing a car. So this angle is 30 degree. Now car is moving towards the tower. Now the angle of elevation changes to 45 degrees. Let the height of the tower be x. So we label it A, B, C and D. Let this distance be x meters. Okay. And this distance we can find out. See, time taken to cover this distance CD is 12 minutes. And let us assume that speed of the car is S. Let speed be S meters per minute. So we can find this distance, multiply speed by time. So we get 12 into S, that is 12S is the distance CD. Okay. See, in triangle ABD, what we can write, tan 45 is equal to AB upon BD, AB upon BD. which is nothing but h upon x, and tan 45 is 1. Tan 45 is 1. So we get x is equal to h from this relationship. We'll solve further. Now take triangle A, B, C. In bigger triangle, in triangle A, B, C. Now we can write tan 30. Tan 30 degree is AB upon BC. Tan 30 is 1 upon root 3. AB is H and BC is 12S plus X. 12S plus X. We can replace this X by H using this relationship 1. So we can write down 1 upon root 3 is equal to H upon 12S plus H. Now we can find S in terms of H. See what we get, 12S is equal to 12S plus H. 12S plus H is equal to root 3H, or 12S is equal to root 3H minus H. That is, take out H common, you get root 3 minus 1. Now S is written as H root 3 minus 1 divided by 12. We have to find time taken to cover this distance, x. So we'll find time taken to cover BD. Okay, this can be written as T is equal to distance upon speed. So distance is x and speed we already know, h root 3 minus 1 divided by 12, which will go in the numerator. Now replace this x by h. So what we get, h into 12 upon h root 3 minus 1. Cancel out h and we get time. So we have to rationalize this number, 12 root 3 minus 1, multiply it by root 3 plus 1. So what you get, 12 multiplied by root 3 plus 1 divided by, on solving the denominator, you get 2. So now we have 6 into 2.732. This will come out to be 16.392 minutes. And this is your answer. Hope you understood these questions well. Please like, share and subscribe. Keep practicing and best of luck for your board exam. Thank you so much.